Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Today, I will present my journal on utilization of Tekelan leaf extract or Promolina odorata leaf based on nanoliposome technology as treatment of antihyperglycemia. I will share my PPT. Okay. Utilization of Tekelan leaf extract or Promolina odorata leaf based on nanoliposome technology as treatment of antihyperglycemia. Introduction. Diabetes or hyperglycemia is metabolic disease that occurs due to abnormalities in insulin secretion and insulin action. Tekelan or Promolina odorata leaf is a traditional plant that can be used as an alternative medicine. Flavonol, 3,4-dihydroxyflavone or quercetin are active compounds in Tekelan leaves, which have antioxidant, anti-proliferative, anti-inflammatory, anti-diabetic, anti-carcinogenic, anti-hypersensitive, and protects against. Quercetin has a weakness in terms of water solubility and high permeability. We need a technology to increase bioavailability so that the maximum therapeutic effect is obtained. Liposomes is one type of drug delivery that can be increased, and the preparation of compounds in the patient's body can increase. And liposomes are basically formed from the interaction between hydrophilic and hydrophobic compounds or between phospholipids and water molecules. With this research, an anti-hyperglycemia test method was developed using male white rats from a nanotechnology liposome from extract of Tekelan leaves. Liposome manufacturing product procedure. The liposomes of the Tekelan leaf ethanol extract were prepared using a thin layer hydration method. The liposome material is made into mixtures, namely mix A consisting of S75 lipoids, DMPG and A lipoids, cholesterol and PAN 60. Mixture B consisting of methanol, chloroform, ethanol extract of Tekelan leaves. The two ingredients are put into a round appliance flash, then evaporate by a rotary evaporator. Heat to a temperature of 60 degrees Celsius with a pressure of 200 millibar for 1 hour. This was done until a thin layer was formed on the walls of the round bottom flash, then 8 ppb into the flash. The liposome results were taken. Furthermore, it's purified with a PD10 column collected into a container, then downsizing is carried out using ultrasonic with sonication times of 2, 4, 6, 8, 10, and 12. Analyzed with particle cell analyzer or PSA, liposome formulation can be seen in table 1 below. The formulation of Tekelan leaf liposomes is ethanol extract of Tekelan leaves, lipoid S75, lipoid DMPG and A, cholesterol, methanol, chloroform, PBS saline. The results of observing the particle size and polydispersion index can be observed in table 3 below. In sonication time on 12 minutes, particle size is 145 0.5 more or less 2.8, and index polydispersion index is 0.307 more and less 0.08. A good liposome particle size is 100 nanometers until 150 nanometer, while a good polydispersity index is 0.7. Polydispersity index is used to determine the homogeneity of the solution. The smaller the polydispersity index, the better of the homogeneity. The sonication time of 12 minutes had a smallest particle size, namely 145.5 more or less 2.8, and polydispersion index 0.307 more or less 0.03. The longer the sonication time will cause the liposome temperature to increase. This is because the energy used to reduce the size of the vesicle change shape to head. At one time, the vesicle size will reach the smallest optimum size. In this condition, the vesicle is relatively more stable. Measurement of blood glucose levels for each stream, the 0, 3, 6, 9, 12, and 15 can be seen in table 5 below. Glucose data show that at a dose of 250 milligrams per kilogram body weight, liposome showed that the 15th day, the lowest amount of glucose was 85 plus drinking 4.30. The result measuring blood glucose levels showed that the liposome nanotechnology extract of Tekelan leaves with a dose of 250 milligrams per kilogram body weight had the lowest value in reducing glucose levels in mice, namely 85 more or less 4.30 milligrams per kilogram body weight. And based on the results of statistical observation, it can be seen that the liposome of ethanol extract of leaves of Tekelan at dose of 25 milligrams per kilogram body weight, 125 milligrams per kilogram body weight, and 250 milligrams per kilogram body weight are not significantly different from glibenclamide dose of 0.45 milligrams per kilogram body weight in terms of reducing blood glucose levels in rats. White meal, however, the three liposomes nanotechnology have significant difference with cmcNA in terms of lowering blood glucose level. The conclusion from this study is that the liposome nanotechnology formulation obtained the lowest particle size in the 12 minutes with a particle size of 145.5 more or less 2.8 nanometer and a polydispersion index of 0.307 more or less 0.03 based on the formulation of the lowest particle size when tested as an antihyperglycemia with a variety of doses. A nanoliposome dose of 250 milligram per kilogram body weight results in the lowest blood glucose levels of 85, more or less 4.30 milligram per deciliter. That's my presentation. If there is anything you want to ask, thank you.